Welcome everyone to the Tech Excellence Conference 2024. We're really excited to be opening this conference by tackling one of the biggest challenges within the software development industry, which is the challenge of software maintenance costs. A short introduction about myself. I work as a technical coach and I help companies to reduce maintenance costs and deliver quality software faster by coaching development teams with TDD, hexagonal architecture, and clean architecture. I'm also writing the Practical TDD in Legacy Code series to help software engineers to practice TDD in real-life projects. So what's the problem with quality and why does quality matter? It matters because when we look at the total cost of software maintenance, the biggest cost does occur in case of bad software quality. So that's the problem. If we have bad quality, it might be lower cost in the short term, maybe in the initial few months or initial few years, but then as we look at the total cost over time, that's when bad quality starts to get exponentially expensive. Whereas good quality software is much lower cost, much more cost effective for maintenance. What do the statistics tell us? So various research has come up with numbers that developers might be spending 50% or 75% of time on debugging. Now, this is wasted time. So what's happening is that developers might be spending maybe 25% of their day actually working on features that deliver value, and the rest of the 75% is wasted. It's wasted on manually debugging their changes to make sure that they didn't break anything. It's wasted on implementing fixes in cases where the developers do find that they broke something. Time is wasted on then retesting those fixes. And furthermore, we repeat this whole cycle as well later when the software goes to QA engineer and they come back with bugs to developers. So we come to this unfortunate conclusion that most developers are spending their day doing wasteful activities. So debugging and bug fixing. And you can look at this research in the link below and search on this further. Now, time is money. So let's take an example of we have one team of 10 developers, and suppose that each developer gets paid $100,000 per year. That means for one team of 10 developers, the total salary per year is $1 million. So imagine what it feels like for management that $75,000 is simply thrown down the drain. It's wasted on debugging and bug fixing, and only a minority, $250,000, is spent on actually valuable work, building features. So this means when we have low quality software that is expensive to maintain, that it takes a lot of time, and that basically developers' salary is wasted. So this is a wasteful cost for the business. But the question is, why? What's the root cause of poor software maintenance? Well, there's not one reason, but the foundational reason is a poor automated testing strategy. So this is the root cause of all other problems related to high software maintenance costs. What happens is that the mainstream approach to automated testing is the inverted test pyramid, which means that companies rely on end-to-end tests as their main automated testing strategy. Developers and QA team work in silos, so it's seen that the responsibility of quality belongs to the QA team. The QA team is there for testing. The developers are there just for coding. These companies may have also some integration tests and unit tests, but a lot less compared to end-to-end tests. And even when they write those integration tests and unit tests, they are written in a bad way. So for example, integration tests for microservice might be testing that microservice connected to all the other microservices, connected to all other external systems. So sort of like an end-to-end test. And furthermore, the way most companies write unit tests is writing a unit test for each class instead of writing unit tests for behaviors. This leads to essentially useless unit tests that are very expensive to maintain, and companies have a false belief that because they reached 80% code coverage that it means something, but this is actually an illusion. So the problem is that the automated testing strategy that's used by most companies results in a test suite which fails to achieve its primary purpose. It fails to provide us with adequate regression bug protection. What's the consequence if we don't have a good test suite? If we don't have any automated tests, or we have an automated test suite, but it's not so good, then it means that we can't do safe refactoring. And when we can't do safe refactoring, we can't get to any cleaner architecture or cleaner code. It means that we are stuck in a big ball of mud. We can't safely improve it. We can't escape this legacy code without the tests. But the challenge is also that the code is untestable. It's too hard to introduce tests. So we are caught up in a vicious cycle. What happens, what's the bigger picture, especially one that's relevant to managers and executives? The problem is that over time, the team that was delivering bad quality software was perhaps very fast, delivering a lot of user stories in sprint 1, a lot of user stories in sprint 2, in sprint 3, but then after several sprints pass, that's when they can't no longer sustain it. So it's like they were able to win the 100-meter race, but they can't win the marathon. It is unsustainable. And they spend most of the sprint time doing bug fixing. But what happens with a team that actually is practicing good technical practices and has maintainable software? They are the only kind of team that can achieve sustainable delivery. So this means that they can continue outputting at a similar pace instead of dropping over time. So that's the thing. It's highly related to delivery sustainability. And you'll see this in many teams where there's bad practices, where managers might say, you were fast before, but now you're slow. What happened? Well, this is the explanation. The root cause is because the software was unmaintainable. So what's the solution to all of these problems? Well, the solution is continuous delivery, which is, as stated by Jez Humble, who is the co-author alongside with Dave Farley of the Continuous Delivery book. Continuous delivery is the ability to get changes of all types, including new features, configuration changes, bug fixes, and experiments into production or in the hands of users safely and quickly in a sustainable way. So the only way to achieve safe, quick, and sustainable delivery is by practicing continuous delivery. Now, to achieve continuous delivery, we require at least a pipeline, and we also require automated tests as well as trunk-based development. Now, zooming in further into automated tests, we need two levels of tests. On one hand, we need developer-facing tests to be able to provide a fast feedback loop to developers, but on the other hand, we also need business-facing tests. For example, acceptance tests to be able to provide feedback. Did we satisfy our acceptance criteria? Now, there's two ways to get to that test suite that's needed for continuous delivery. We could use test-driven development, or we could use test-last development. Here, it is preferable to use test-driven development because it naturally leads to basically a highly reliable test suite, which means higher protection against regression bugs. So this is it. The solution is there. We've already known the solution for a decade or 2 decades, but unfortunately, still not many companies practice it. But this is the only solution, continuous delivery. And as we can see, tests are a huge aspect of continuous delivery. If you don't have an adequate test suite that provides you with a way to safely and quickly go to production, then you are not practicing continuous delivery. So on the topic of what is a good test suite, the way that most developers understand automated testing is with the old test pyramid, which consists of end-to-end tests, integration tests, unit tests. The problem is that end-to-end tests are the only kind of tests here which provide us with system-level feedback, but one problem with end-to-end tests, which are typically long Selenium tests or long Cypress tests, is that they are basically very hard to maintain and do not enable us to adequately test user story acceptance criteria. The other also problem is that the way that developers practice integration testing is actually very similar to end-to-end testing. For example, we're testing one microservice connected to all the other microservices it connects to and the other external system that it reaches. So it sort of has the same problems as end-to-end tests. And finally, the way that most teams practice unit tests is write a unit test per class rather than coupling it to behavior. And basically, these tests are also poor at protecting us against regression bugs, and they are very hard to maintain. And this is why we need the new test pyramid. So in the new test pyramid, there will be very few smoke tests and end-to-end tests for system-level testing. Instead, majority of system-level tests will be acceptance tests. Now, the benefit of writing acceptance tests, especially with Dave Farley's 4-layer model, is they are a very maintainable way to be able to test acceptance criteria of user stories, which is great. So they provide us with very reliable end user business-facing feedback. Does our software accomplish the user story acceptance criteria? And we also have external system contract tests to verify, hey, do we correctly integrate with external systems? Then, so that's like topmost system level testing. Then we zoom down into our system. Most likely we have a front end, we have a back end, or perhaps even microservices. So then we have a front end team, we have a back end or team or microservice 1 team, microservice 2 team, microservice 3 team. In the old test pyramid, it was not possible to test one microservice in isolation of each other. So the team did not get feedback for does their component work. This we solve it with component tests. So by writing component tests, the front-end team can get feedback. Does front-end work in isolation from everything else? The microservice 1 team can get feedback. Does microservice 1 work in isolation from everything else? Notice that I said in isolation from. But then how do we test whether they can communicate properly with each other? Well, that's why we need contract tests. So for example, contract tests between front end and back end. Contract tests between microservice and microservice 2. Can they integrate well? Then let's go even to the most granular level. Let's zoom inside one component. So inside one, for example, microservice, especially one that has high business complexity. We would like to be able to independently test business logic in isolation from infrastructure and presentation. So we would use unit tests to be able to test business logic, and we would use narrow integration tests to be able to test presentation logic and infrastructure logic. And if teams start practicing essentially adopting this new test pyramid, they will be getting feedback at all the right levels. So acceptance tests provide business-facing and user-facing feedback, whereas component level and unit level tests help provide better developer feedback and reduce all of that wasted time on debugging. And here I've just visualized the same thing, but instead of a pyramid as a spectrum. So basically, smoke tests and end-to-end tests, which should be the ones that we should have the least of these test types, they span everything, our system and external systems. Whereas acceptance tests, they span our system in isolation from external systems and provide us with feedback. Did we achieve acceptance criteria? And we have separate tests for essentially testing the contracts of external systems. Then we zoom into the components, which was, for example, front end, microservice 1, microservice 2, etc. Each component has its component tests to verify the whole component and contract tests to verify can this component communicate with other components. And then furthermore, in cases where we have a complex a component with complex business logic, we zoom in further and have unit tests and narrow integration tests, whereby the unit tests serve an important purpose of verifying the business logic, whereas narrow integration tests are testing at the boundary, communication with the IO essentially. The challenge for many companies is that they are stuck in legacy code. So the question is, how do we get to this new test pyramid that we really need? Well, you can't do it in one day or 1 week or 1 month. It will take longer. So based on my experience in technical coaching, we can split this process in phases. So first of all, we need to set up the pipeline. So commit stage for providing feedback to individual teams, and acceptance stage for providing feedback for the system overall, and also release stage to be able to release or to, let's say, staging a UAT. Then when we have the pipeline with placeholders for the tests, that's when we can start introducing testability, automated testing, and test-driven development at various levels. So let's go top down first. Let's firstly introduce system level testing. So that means we need to clean up our end-to-end tests, migrate a lot of them to acceptance tests and external system contract tests, and to be able to practice acceptance test-driven development. And this gives us safety that we have assurance that our software satisfies acceptance criteria. Then we can move on to improving developer efficiency by eliminating debugging. Now, at the first level, again, we're going top down. Let's solve the problem of inter-team communication. So to avoid a lot of conflict between front-end microservice 1, microservice 2, like debugging who is at fault, that's why we need component level testing. So component tests and contract tests, and to be able to practice test-driven development at the component level. And lastly, for components, especially ones that have high business complexity, we need to introduce a unit testable architecture, such as hexagonal architecture, to introduce unit tests, narrow integration tests, and to be able to practice test-driven development at the unit level. All of this, it's already a long journey, but this is the foundation. This provides you with a safety net. Then, when you've achieved this is the foundation. Now you can continue your further journey towards software quality. So you might be doing further improvements in your architecture, in your code. You might be doing some performance optimizations. You could be doing anything else. But these first 4 phases are the foundation that enable you to move further on with your journey into software quality. So if you would like to learn more about this, feel free to check out my TDD in Legacy Code series. Now, solving this problem of software maintenance is a very difficult challenge that's facing our whole industry. And that's why we founded the Tech Excellence community. And our vision is to raise the bar of technical excellence across the world. Here are some of our upcoming speakers who will be joining us today. So we have both Europe sessions and we also have USA sessions. Thanks a lot to all of my great co-organizers. It was a big challenge to organize this, but we're really looking forward to making an impact across our community. And also you can check out our sponsors if you want to learn more. So our sponsors provide you with useful learning resources. And feel free to join us on Meetup and follow us on social media. So I would like to say thank you, everyone. And now we have several minutes to go through some questions. So it might be questions about software maintenance costs, anything you've seen in this presentation, or it might be about the rest of our conference or anything else. So I'm now open to questions.
Great talk, Valentina. And I need to mention that we already broke a record because we have a lot of people watching this. So thanks for everyone. Yes, we have a question. Maybe you could elaborate on that. So let's do it. So here it is from Giorgio. Could you elaborate on narrow IT? So there was a point.
Okay, narrow integration tests. So good question. So Martin Fowler wrote an article which is called Integration Tests, where he explains the two different integration test types. So we have broad integration tests and we have narrow integration tests. Most developers, including myself in the past, were practicing broad integration tests. So a broad integration test of, let's say, microservice 1 is testing the that microservice 1 connected to all the other microservices it connects to and connected to all the external system it connects to. So that's a broad integration test. A narrow integration test is essentially, let's go into that microservice and only look at its boundary that communicates with I/O. So we would have, for example, some classes within microservice 1. So some classes that connect to microservice 2 or microservice 3 or external systems like PayPal. And then we would test those classes in isolation. Furthermore, important note there is that we would not be connecting to real instances of the other connected microservices, nor connecting to the real instances of the other external systems, but instead we may use, for example, tools like WireMock to simulate out all those other connected microservices and external systems. So thanks for that question. That's a very good one, because again, most developers are familiar with broad scope integration tests, which result in essentially very bad maintenance, but actually narrow integration tests are the way to go.
Excellent, very detailed. Thank you very much. Now, do we have time for one more? We have.
Yes, I think we could squeeze in one more.
Well, that is a really great one. I bet you could talk about it for a long time, but let's make it short. So the question is from Ivan: what is the role of QA engineers in your approach?
Excellent. So sometimes QA engineers might be worried, does this mean no QA engineers? No, it actually means putting QA engineers into a much more valuable role. So currently QA engineers spend their time doing a lot of manual regression testing and not enough time to be able to focus on, let's say, the new user story or thinking from, usability, or does this satisfy business need? But they just are chasing to cover the regression test suite. With this new approach, especially with acceptance test driven development, it means that regression testing will be fully manual. So that means QA engineers will no longer be doing manual testing, but instead what they will be doing is a much more valuable activity, which is exploratory testing. So they'll be able to play around with the new user story and see also does it satisfy business needs. So yeah, that was another good question. And I think, Daniel, I think we could end with one more at the end, which I would like to share about TDD. So in my experience, if developers learn how to do TDD properly, they will become better developers, even if they do not get to practice TDD in all projects. So investing time in this skill set is a no-brainer. This is very well said. So by practicing TDD, it helps us learn design skills to be able to design testable software, and it also helps us provide protection against regression bugs so that we have safety to further improve our code. So thanks for that note. Yeah, so I think these were excellent questions, and feel free to further write any comments on YouTube, which I may also look at after this session. So yeah, and together with the rest of our organizers, we're really looking forward to the next talk. And indeed, our next talk is Dave Farley. So looking at modern software engineering, building better software faster. So see you there. Thank you, everyone.
You can find the link below in the YouTube chat, so check it out and see you there. We start in 3 minutes.
Thank you.
Thank you. See you.
Bye.